All right, I'm back. We're on page 283. We're like in the middle. We're probably in like the almost actual middle, right? There's like two full problems, half a problem, two full problems. I think we're in the exact middle, right? Anyway, we're on this problem. And we need to turn this into something that we can deal with. It doesn't say that we have to do a change of variables. So let's not do a change of variables. Let's take a look at this. So immediately I look at it and I think if I substitute 0, I get the tangent of 0, which is 0 over 5 times 0 is 0. Got to do some stuff. Direct substitution, not working. So I see a tangent, so I'm going to like do something with that. Also, that 5 in the denominator, not really doing anything for me, so I'm going to constant multiple rule that out. So first, I'm going to say it's 1/5, right? So constant multiple, pull that out. Limit as x approaches 0 of sine of x, or sine, so it's going to be sine. Why am I talking so slowly? It's going to be the sine of 2x over the cosine of 2x, right? Because that's tan of 2x. And then I don't know why I'm writing it in this order, 1 over x. Okay, so far so good, I think. All right, so now what can we do here? Well, sine of 2x over 2x would be perfect. Close to perfect would be sine of 2x over x. So I'm going to choose to go with, we got 1/5, and then it's going to be the limit as x approaches 0 of sine of 2x over x, because I think I can deal with that. I have some ideas of what to do there, times the limit as x approaches 0 of 1 over cosine of 2x. All right, am I allowed to do this? I'll find out if I'm allowed to do it when I try to do it and get an answer. If I get an answer, yes, I was allowed to. If I don't get an answer, then no, I wasn't allowed to. It's like, it's always easier to ask for forgiveness than it is to ask for permission. That's another one of those rules in life that you probably shouldn't follow, and you didn't hear it from me, but that's a thing that people say. So how can I fix this up? If I look at 1/5 is done, obviously. The cosine of 0 is 1, so like that right-hand limit there is actually just 1 over 1, so that's done, that's 1. I need to deal with this thing in the middle. I see sine of 2x, so what I'm going to do in a different color to make it clear what I've done is I'm going to multiply by 2 over 2. And 2 over 2 is 1, so I changed the way it looked, but I didn't change the value, so that's good. So now I'm going to have 1/5, which is done. I'm going to pull out the 2 from that limit, so 2, then I still have the limit as x approaches 0 of sine. So we're showing like enough work that we think anyone could follow it, which is kind of your goal. Like you assume that the person reading your work knows the math, knows at least as much as you do, but that they're like maybe not the carefulest of readers, the most meticulous reader. And so we try to show enough work that they can follow it. So this will be 2 over 5 times our limit. We just engineered that limit to be 1. So that's 1 times 1. So we get, my stylus has let me down. You know, sometimes I just get these weird things that I can't erase. Can I cut it? Cut. Go. And go. I cut it. All right. I can cut, copy, paste, but I cannot erase. That's weird. 2/5. All right, so that's a little weird. That's a weird one, no doubt about it. But, you know, not that bad. All right, and that one did not say to use a change of variables, so I didn't use a change of variables. Instead, I just like went for it, used some techniques that I knew. It was got to follow the directions. All right, investigate this limit graphically and on your calculator, which means on a calculator page. So the result is so nice, it seems like there should be a straightforward way to do this by hand, but I have never found it. I'm confident that there is a way to do it because the answer is just like too nice. There has to be a way to do it. All right, calculator. I'm just gonna start a new document. I feel like you start a lot of new documents. It's a good idea to like store things and whatever, but like, you know, can't make you do it. All right, let's look at the graph. X minus sine of x. I'm expecting this graph to be nuts because like it's got a lot of asymptotes, like anywhere sine is 0, anywhere 1 minus cosine is 0, so anywhere cosine is 1, which actually I guess cosine is 1 in the same place as sine is 0, but sine of 0 is 0. Cosine is 1 in the same places that sine is 0, but sine is 0 in more places than cosine is 1. Think about it. Unit circle. All right, so let's see. Okay, yeah, so weird graph. Do I really care what the graph looks like? Probably not. But look at that thing. And like, what are these? It seems to definitely have like a slant asymptote type situation, like 2 of them. But like, what are they? I don't know. Let's see. There's like things we could do to try to figure that out, but like we don't know enough math yet, so I don't want to like, I want to, but I don't want to like cloud your judgment. Let me just trace right now. Menu 5, trace it to 0. At 0, undefined. Really? 0 over 0? Yep, 0 over 0, undefined. But what's it close to? 0.001. Okay, let me trace 0.001. All right, hold up. Menu 5, enter, and 1. Okay, we're out. 0.001. 0.0001. Ooh, what do you think that is? 0.333334? I have a guess. And that's not right. Let's try again. Negative point. It rounded. Ooh, 0.334. 333. I think every time I'm saying the wrong number of threes. It doesn't matter. It feels like it's very 1/3-ish, right? Let's go here. Let's do the limit as x approaches 0 of, I have it stored in f1, so I'm just going to use f1 of x. 1/3. It's exactly 1/3. Why is it 1/3? That's such a nice answer. Seems like you should be able to like algebraically manipulate this thing and get that to show up, but like, I don't think you can. So I don't really know what's going on there. I've never found the way, like the secret way. I don't know where I like first ran into this problem in life, or if I was just like cobbling stuff together. I don't know. But anyway, the limit as x approaches 0 of x minus sine of x over sine of x, 1 minus cosine of x. Whoosh. Hope you were hoping to make a lot of parentheses. Is 1/3. What the heck? 1/3 is such a nice answer. There's got to be a way to do that by hand that doesn't involve like advanced calculus strategies. Like I can get it, but it would involve calculus stuff that we don't know yet. But that's such a nice answer that it seems like we should be able to do it. All right, let's see. 283, which I believe to be the last page of these notes, despite the fact that on this app, I have another page, just like a little bonus page there. All right, find the exact value of the limit as x approaches 0, 1 minus cosine of x over sine of x by being tricky smart. So what does that mean? Who knows what that means? It means evaluate this thing. So I look at this limit. I'm going to show you 2 ways to do it. I look at this limit and I think this looks an awful lot like the 2 limits that I memorized, but like just a little different. So what I'm going to do is try to make it look exactly like the ones that I memorized. Also, spoiler, we memorized 3 limits because one of them is just the reciprocal and it still works, and I need to know that like right now. So what I'm going to do is the limit as x approaches 0 of, by the way, if you substitute in, you get 1 minus 1 in the top and you get 0 on the bottom, so you get 0 over 0, so we're allowed to mess around. Should always be checking that. Sometimes I forget because like they're all 0 over 0, and that's why we can like do stuff, but should be checking. All right. 1 minus cosine of x over sine of x. So what can I do to make this look like the limits that I memorized? I can multiply by x over x. This is nuts. So you're allowed to do that because x over x is basically 1. Not basically, it's 1 as long as x is not equal to 0, but we're taking limits, so it doesn't really matter. So we have this, and now, am I allowed to break this up into 2 limits? I am definitely allowed to, as long as both limits exist. If they don't both exist, then I'm not allowed to do it. It's a bad strategy. Try something new. If they exist, you were allowed to do it. It was a great strategy and good work for you. So that's how it goes. You're either the hero or the goat, right? So I'm gonna make it 1 minus. Although goat in recent years has come to mean greatest of all time, and I feel like, so now people have a more positive association with being a goat. The goat. I get not a goat. I don't know what it means to be a goat. You're just like the town goat. Okay. Like there's that goat again. All right, let's see. So this, the first limit we memorized was 0. And if you didn't memorize them, you can't really do the problem, and that's why you have to memorize the things I tell you to memorize. The second one is 1 because it's the reciprocal of the very famous one that we memorized. I don't know why that one's more famous than this one, but you know, it doesn't matter. So we get 0. Okay, so that's a good way to do it. That's tricky smart for sure. Multiplying by a clever form of 1. It's right in the name, clever form. Another thing you can do you recognize this a little bit potentially from some things that you've done in the past? I think you do, maybe, or should. If you look at that, that looks like one of the identities that we had to mess around with a lot. And it turned out you could show that that equaled like all kinds of things. I'm going to do something from the archives, if you will. I'm going to start with this. 1 minus cosine of x over sine of x. And then I see 1/2 of a Pythagorean conjugate situation. I'm going to multiply the top and the bottom by the other half. 1 plus cosine of x. It's like, will this work? Does knowing trig identities and the 14 formulas and fundamental identities, does that still apply? I think it does. All right, so 1 minus cosine times 1 plus cosine is 1 minus cosine squared, but 1 minus cosine squared is equal to sine squared. So this is now sine squared over, and remember, it's the same rules with rationalizing anything. Like expand the part that you're rationalizing, never expand the other part. So we rationalize the numerator, Pythagorean conjugated the numerator. So don't expand the denominator because that's not where we were doing this. Plus cosine of x. Okay, let's cancel. I swear, if you see this as like the first way to do it, it's fast, right? We already did it once, so this feels ridiculous. Here we go. Okay. Now, substitution. Sine of 0 is 0. If the denominator is 0, we like move on with our lives and try something else. If, however, the denominator is not 0, we are done because 0 divided by something other than 0 is definitely 0. So 0 divided by cosine of 0 is 1, so 2. 0, check. We got it 2. That's a weak check mark. Check. Woo, look at that check mark. Okay, so that was pretty good. We're doing a lot of limits, a lot of trig stuff, limits to infinity, whatever. These notes had a ton of stuff in them, 26 pages long. Definitely take a minute. Just think about what you've accomplished at this point. It's a ton. So after you're done taking that minute, like join me in the next video and we're going to keep going. So I hope you are finding these helpful because I really want them to be, and they're a ton of work if they're not. So I will see you in the next video.